Hello students, welcome to the new chapter of 12th Physics 2. The chapter name is Semiconductors. Semiconductors, we have already learned the basics of semiconductors in our 11th standard. So we'll be continuing that study and we are going to learn the new devices apart from the PN junction diode, and we'll be learning about their uses, advantages, disadvantages, and how to operate the device, what is the use of that device. All these things we are going to learn in this chapter, semiconductors. So let us start with the topic, and the first one is we'll see the overview of the chapter. What the things we are going to learn in this chapter is the first one will be the introduction to the chapter. We'll be introducing the semiconductor chapter. With we can say we will be revising some concepts from 11th standards that we have already learned. The second is the PN junction diode as a rectifier. We have already learned PN junction diode. We'll be learning PN junction diode as a rectifier. What is rectifier? Rectifier is an electric circuit which is used to convert alternating current to direct current, which is used to convert AC to DC. This is called as rectifier. And PN junction diode, it is used for rectification purpose. PN junction diode, it is used for converting alternating current to direct current. We are going to learn this. Then we'll be learning about the half wave rectifier. Half wave rectifier, the use of only one diode in this half wave rectifier. We'll be learning about the full wave rectifier. So there will be the use of two diodes in this case, in the case of full wave rectifier. So we'll be learning about the circuit diagram of this full wave and half wave rectifier. Next we'll be learning is the ripple factor, and after that we'll be learning is the filter circuits. So how we are able to get a pure DC. So these are the steps after a filter circuits. We'll be getting a pure DC. These are the steps. We'll be learning these steps in detail in the next subtopics. After that, we'll be learning about the special purpose junction diodes. Apart from the PN junction diode, we have already learned PN junction diode in the 11th standard in detail. We'll be learning the next Zener diode. So, what is the use of Zener diode? Zener diode, it is used for voltage regulator. It is used for maintaining a constant voltage across the circuit, across the output terminal, and the Zener diode is always attached in the parallel position with respect to the output load, and the Zener diode, it is there operating in the reverse bias condition. Okay, so we'll be learning this Zener diode, how it is used as a voltage regulator in the next subtopics. After that, we'll be learning about the photodiodes. The photodiodes are the special type of PN junction diode in which it passes the current electricity when a light of particular intensity it falls on its PN junction. It falls on its depletion region. So this photodiodes, they are always connected in the reverse bias direction, and whenever a light of particular frequency it falls on the depletion region, then we can say the photodiode it conducts. Okay, so we'll be learning about this photodiode in the next subtopics. Next is the solar cell or photovoltaic cell. We all know what solar cells are used for. The another name of solar cell is photovoltaic cell. Solar cell, it is used to store electrical energy. It is used to convert solar energy into electrical energy. And how we are able to do this is again, it is a special purpose PN junction diode. It is nothing but a PN junction diode only. It is made in such a way that it has the ability to store electrical energy. Okay, such that if it is charged, then it can be used as a cell. Hence, the name is solar cell. Next is the light emitting diode LED. We all know LED. Whenever you supply a power to the LED, whenever you connect an LED to a battery, then what is going to happen is that LED will start glowing. Okay, it will emit light. So that's why this the special purpose PN junction diode. That's why it is called as light emitting diode. Whenever it is forward bias, it is going to emit light of particular frequency. Particular frequency means particular color. So it is going to emit a light of particular color from its depletion region. Okay. So this is what the light emitting diode is. The next we are going to learn is the bipolar junction transistor. So in the PN junction diode, we were having only one junction, that is between P and N. Now, to a silicon substrate, uh, two sides are P-type dope, and in between it is N-type dopes, and then we can say it is PNP transistor it is forming. So this transistor contains two junctions, okay, between P and N, and after that N and P. Or it can be in the another way that on both sides N type impurities are doped, and in between P type impurity is doped, then it will result into two junctions, NP and PN. Okay, so let me um, draw like this. In the case of PN junction diode, one side is P-type dope and other side is N-type dope. So there is a formation of only one junction. So this is what one junction it is formed. Okay, but in the case of bipolar junction transistor (BJT), it can be a situation that two sides are P-type doped and in between there is an N-type dope, such that there are two junctions are there. Or in the another way, it can be like this: both sides are N-type dope and in between P-type impurities are dope, such that it will be NPN transistor, and this is called as PNP transistor. Okay, so these are the things in the bipolar junction transistor. Why it is called as bipolar junction transistor? Because I can say that it has two um, junction. So remember that for one junction we require one battery. So for two junction we require two batteries. Such that two electrical connections are required in the case of BJT. I can say it is then bipolar. What it is called as? This is called as bipolar. And how many junctions are there? Five junctions are there. Two junctions are there, and this name it is called as transistor. This is called as transistor. That means the transfer of resistor, or I can say it can be used as a variable resistor. It can be used as a variable resistor. Okay, so BJT. So in BJT, we are going to learn about the common emitter configuration. Actually, there are three configurations: common base, common selector, and common emitter configuration. Among that three configurations, we have common emitter configuration in our syllabus. So we are going to learn about the common emitter configuration in detail. We'll be learning how the current electricity it passed through the transistor. Transistor is a three-terminal device. Okay, so these are all things we are going to learn in detail whenever the part of bipolar junction transistor will come. Okay, then we'll learn about the common emitter characteristics. We'll see some important characteristics of common emitter amplifier transistor. Sorry, common emitter transistor. And then we will be looking at the application of transistor, how this transistor it can be used as an amplifier, how this transistor can be used as an amplifier. After that, we'll be learning about some logic gates. Logic gates are nothing but we can say it is the logic in which if suppose both the statements are true, then only the output is true. If both the statements are false, then the output is false. So it depends on, there are many types of gates. Example is NOT gate. NOT gate means inverter. Whatever if you say, if you send one, the output is going to be zero. If you send zero, the output is going to be one. Then this is called as NOT gate. The another one is OR gate. OR gate means the output will be zero if all the inputs are zero. If any one of the input is high, then the output is going to be high. So this is what one type of logic. We are going to learn in detail whenever we study this OR gate, NOT gate, and logic gates. And after that, there is a AND gate. AND gate is nothing but a gate in which the output is high if all the inputs are high. If any one of the input is low, then the output of the AND gate is low. The next is the NAND gate. NAND gate is the opposite of the AND gate. AND gate is the opposite of the AND gate. That means if all the inputs are low, then only the output is high. If any one of the input is high, then the output is low. So this is the opposite of AND gate. Similarly, we have a NOR gate. NOR gate is the opposite of OR gate. So in the case of OR gate, if all the inputs are low, then only the output is low. Otherwise, it is high. In the case of NOR gate, it is opposite. If all the inputs are low, then the output is high. But if suppose any one of the input is high, then we can say the output is low. Okay. And the next one is the exclusive or exclusive NOR gate. Okay. Exclusive OR gate, which is also called as XOR gate. So we'll be learning how this OR gate, it has a drawback such that we have to build a special type of OR gate. So that special type of OR gate is called as exclusive OR gate. Okay. So we'll see what is the drawback of the OR gate and what was the reason behind we were um, we have to build a new type of OR gate, a special type of OR gate which is called as exclusive OR gate. Okay. And after that, this will complete our theory part, and then we will see the MCQs from the textbook, and also we'll look at some numericals. Okay, so let us start with the topic of semiconductors. So we'll revise the things from the 11th standard. So what are semiconductors? Semiconductors are the devices which has the properties intermediate between conductors and insulators. Semiconductors are the devices which contain four electrons in their outermost shell, right? And because of this four electrons in the outermost shell and the covalent bond, I can say a pure form of semiconductor, it is called as intrinsic semiconductor. So this is what intrinsic semiconductor, and there in the classification of semiconductor, intrinsic semiconductor. So this is what an intrinsic semiconductor. So intrinsic semiconductor, it is called as pure form of semiconductor. It is what pure form of semiconductor. A pure form of semiconductor, it is called as intrinsic semiconductor. Okay. Now, if you add impurity to this intrinsic semiconductor, so this is what adding impurity. So if you add impurity to this, then the intrinsic semiconductor will become extrinsic semiconductor. So this is going to be extrinsic semiconductor. So an extrinsic semiconductor, this means what? Impure form of semiconductor. Okay. So why are we adding the impurities? In order to increase the conductivity of the semiconductor, we are adding the impurities. Now, impurities can be a trivalent impurity or a pentavalent impurity. Depending upon that, we can say that the semiconductors are classified into two categories. The extrinsic semiconductors are classified into two categories, and they are P type of semiconductor and N type of semiconductor. So extrinsic semiconductors are classified into two categories. The first is P-type semiconductor, and the another one is N-type semiconductor. Okay, P-type means positive type of semiconductor, and N-type is negative type of semiconductor. Okay, so if I say the positive type of semiconductor, so trivalent impurities are there. Trivalent impurities, that means the impurities which contain free electrons in the outermost shell, they are added to this P-type of semiconductor, and N-type of semiconductor, I can say pentavalent impurities. Pentavalent impurities which contain five electrons in the outermost shell, they are added to this type of semiconductor. Okay, so all of you can pause the video, you can write the things down, which is already we learn in 11th standard. Okay, so what I consider the conductivity device, so if I consider the conductivity, the conductivity of intrinsic semiconductor, it is very less. The conductivity of intrinsic semiconductor, it is very less. And then this is what P type of semiconductor. The P type of semiconductor conductivity, it is more compared to the intrinsic semiconductor, and the highest it is of N type of semiconductor. So if I consider N type of semiconductor, the conductivity of this semiconductor is very high. Why? Because the mobility of electron is more compared to the mobility of holes. So I hope you know the concepts of free electrons and holes. So in semiconductors, the current electricity flows because of the free electrons, the flow of free electrons as well as holes. But in conductors, I can say The current electricity flows because of only three electrons. Okay. So in the case of intrinsic semiconductor, the conductivity of intrinsic semiconductor is very less, and the conductivity of N type of semiconductor is very high. Okay. So if I consider the devices, if I want to make some devices, then we consider the silicon substrate. So this is what a silicon substrate. So on one side of the silicon substrate, we do trivalent impurity, and on the other side we do a pentavalent impurity, such that this is the positive type of semiconductor, and on the other side this is the negative type of semiconductor. In between the positive and negative type of semiconductor, there is a formation of junction. So this is what a junction which is formed. So this is junction which is formed between P type, positive type, and negative type of semiconductor, right? So this device, it is called as PN junction diode. PN junction diode. PN junction diode. So what is PN junction diode? What is the use of PN junction diode? I can say the use of PN junction diode is it is used for it is used for unidirectional flow of current. It is used for unidirectional flow of current. Unidirectional flow of current. It is used for unidirectional flow of current. That means, if suppose I say the PN junction, it is got forward bias. So if it is forward bias, it can be considered to be on. Okay. So if it is a reverse bias, then we can say it can be considered to be off. Okay. So what is called as forward biasing? Whenever the positive terminal Whenever the positive terminal of a battery it is connected to P type of semiconductor and negative terminal of a battery it is connected to N type of semiconductor, I can say the PN junction diode is forward bias. And if suppose the negative type of semiconductor it is connected to positive terminal and positive is connected to negative terminal of battery, I can say it is the reverse bias connection of the PN junction diode. So in the case of forward bias condition, the diode is going to be on, while in the case of reverse bias condition, the diode will be off. Okay, so because of this on and off, the switching behavior, I can say this diode it can be used as a rectifier. So in the rectifier circuit, this diode can be used. So what is the rectifier circuit? Rectifier circuit is nothing but an electrical circuit which is used to convert alternating current to direct current. Okay. Now, what is the alternating current and what is direct current? Why we require alternating current? So this is what alternating current, and this is what direct current. Remember that direct current it is denoted by capital D, capital C, while alternating current it is denoted by small a, small c. So this is what alternating current and direct current. Now, alternating current, it is very simple and very convenient and very cheap to produce. So that's why we produce alternating current. So we produce alternating current. Okay. Also, so cheap to produce. Okay. Also, production cost is going to reduce if suppose we are generating alternating current instead of direct current. Okay, so less loss. The next point is less loss during supply. So whenever alternating current is getting supply from the power station to this our home, okay, so the supply loss is very less and it can be neglected because of the alternating current. But if suppose you consider direct current, so direct current will have more losses. Okay, so this is the convenient way of generating current electricity. I can say the government it is accepting the alternating current procedure for development of current electricity. Okay, so in India we can say the alternating current which is coming to our house is 230 volts and 50 hertz. 230 volts, 50 hertz. Okay, so this specification is going to differ from country to country. So if you are purchasing a module from different country, so you should know its power ratings and the supply ratings, okay, such that it is compatible with Indian power requirement or not. You should be able to note these things. Okay. So most of the electronic components, for example, your TV system and many other things, they just work with direct current. So it is very much necessary for converting the direct this alternating current to direct current. It is very much necessary to convert the alternating current to direct current. Okay, and this process of converting an alternating current to direct current is called as rectification. It is called as what? Rectification. So alternating current it will look like this. Alternating current is look like this, a sinusoidal alternating current. While direct current it is going to look it will be a straight line. This is what a direct current and that is what an alternating. So in order to supply the current to this remote control or radios, okay. So they require direct current. So they should have a rectification circuit inbuilt in it. Okay. So this is what the introduction. So we are having an alternating current and we want that alternating current to convert it into direct current. So what are the various steps which is available in order to convert the alternating current to direct current? So this is the first I can say AC mains 230 volts RMS 50 hertz. So this is the supply which is present for India. That supply it is for India. So Indian supply I can say it is 230 volts 50 hertz supply AC supply. This is what a transformer. Transformer means it does not provide any physical wire connection between the source and the receiver. Okay, and I can say it is used for electrical isolation, such that no direct wires are connected. But transformer used over here is 1:1 transistor transformer, sorry, 1:1 transformer, in which if suppose someone says 5 volts, then the answer the transistor will gain is the 5 volts. Okay, so this is called as 1:1 transformer. So if it is 1 to 2, if it is 1 to 2, then if suppose here the input is 2 volts, the output is going to be 4 volts. So this will be multiplied by 2 like this. But now it is for simple understanding, it is 1:1. That means whatever is the input, same is the output. So for what purpose it is used? It is used to it is used to convert alternating current to direct current. So this is what the transformer. Transformer it is used to provide electrical isolation between the source and the receiver. Okay. So whatever is the current present here, that this is going to be the current which is present here. So this is what the alternating current. This is also the alternating current. Now, if suppose this diode, it is the rectifier circuit is a full wave rectifier. So if it is a full wave rectifier, so that's why we are getting the output like this. We are getting the output like this. Okay. Now this type of output I can say this is called as pulsating DC. What this is called as pulsating DC. Okay. And this pulsating DC has to be converted into a straight line. So first we will be passing that through a filter circuit. Filter circuit is nothing but the presence of capacitor. The presence of capacitor. So this is called as filter circuit. So whenever you apply capacitor across the junction, you will be noticing that there will be some small spikes like this, so that it is not constant, but it is like this, right? So this is what the filter output. Okay, and after that it is passed through a voltage regulator. So voltage regulator it gives you the constant supply. A voltage regulator you can say it is the Zener diode. So voltage regulator is nothing but a Zener diode. Okay. So I hope you understood the overall mechanism of converting the alternating current to direct current. So we are going to learn in the subtopics. Okay, so in the subtopics we'll be learning about these all things in detail. Okay, so the next topic that we are going to learn is the PN junction diode, which is used as a rectifier. Okay, in the rectifier circuit. Thank you so much for paying attention. We'll meet in the next subtopic. Till then, take care. Goodbye. Bye bye.